Okay, so here in the uniform flow, the flow parameters such as depth of flow, velocity of flow, slope of the channel, you know, this is the I, okay, slope of the channel, and cross-sectional area, cross-sectional of the area means cross-sectional of the wet area means this is the wet area, is the channel flowing, the depth of the water, it will be Y or D. Okay, this is the cross-sectional wet area, is not going to change with respect to the length of the channel. With respect to length of the channel means is the velocity, discharge and slope, cross-sectional area and depth at section 1 is equal to the same at the section 2. Okay, the depth, velocity, discharge and slope of the bed all are same at section 1 and at section 2 is called as uniform flow. Means the simply we can define the flow parameters such as depth of flow, velocity of flow, depth of flow, velocity of flow, and the slope, bed slope and discharge and cross-sectional area is not going to change with respect to the length of the channel or with respect to the space is called as a uniform flow. Means it should satisfy the conditions dy by dt is equal to 0, dv by dt is equal to 0 and dq by dt is equal to 0. Sorry, here dy by ds, okay, dv by ds and dq by ds. Okay, here with respect to space, right, with respect to the length, so dy by ds is equal to 0, dv by ds is equal to 0 and dq by ds is equal to 0. Means here the depth of the flow, velocity of flow and discharge rate of flow do not change with respect to the space, is not going to change with respect to the space. Okay, let us see here, this is the section 1 and 2. So here the v1, q1 and y1, okay, v2, q2, y2, so the values will be the same. Okay, v1 is equal to v2 and q1 is equal to q2 and y1 is equal to y2. Okay, here the both the velocity, discharge and depth is the same at the section 1 and 2. Okay, so you got the clear pictures about uniform flow. Uniform flow means the flow parameters such as a depth of flow, velocity of flow and slope of the channel and cross-sectional area of the flow do not change with respect to space, okay, or length of the channel. Okay, so here it should satisfy all these three conditions. For uniform flow, it should satisfy all these three conditions. Okay, next we can go for the non-uniform flow. Okay, the non-uniform flow means the flow parameters y, depth of the flow, velocity of flow, discharge of flow, slope of the bed, cross-sectional area is going to change with respect to the length, means dy by ds not equal to 0, dv by ds is not equal to 0 and dq by ds is not equal to 0. Means here the depth of the flow, velocity of flow and rate of flow is going to change with respect to the space or the length of the channel. Okay, here see here, okay, here v1, q1, y1, v2, q2, y2. Okay, v1 not equal to v2, q1 not equal to q2 and y1 not equal to y2. Okay, here the flow parameters such as velocity of flow, rate of flow and depth of flow is going to change with respect to the space or with respect to the length of the channel is called as a non-uniform flow. Okay, so if it dy by ds is not equal to 0, dv by ds equal to 0, dq by ds is equal to 0 is also called as a non-uniform flow, because in uniform flow it should satisfy, already I told, should satisfy all these three conditions. Means it should is equal to 0. Okay, in this also non-uniform flow. Okay, next, the non-uniform flow is classified as, you know that this non-uniform flow is the varied flow. Okay, it's also called as a varied flow. The non-uniform flow in open channel is also called as a varied flow. Okay, it's also classified in the following two types. The first one is gradually varied flow. The first one is gradually varied flow. Then simply we can write as a gradually varied flow. Okay, see here the non-uniform flow is classified as a, the first one is gradually varied flow and second one is rapidly varied flow. Okay, rapidly varied flow. The first one gradually varied flow and second one is the rapidly varied flow. Okay, see here gradually varied flow means is the type of uniform flow in open channel where the fluid depth changes gradually over a long length of the channel. See here the fluid depth in a gradually varied flow, the fluid depth is gradually changes over a long length of the channel is called as a gradually varied flow. Okay, over a long length of the channel. Means rapidly varied flow means is also non-uniform flow. Here the depth changes suddenly. Okay, the suddenly depth changes and drop down. Okay, suddenly changes the depth over a short length of the channel. Okay, over a short length of the channel is called as a rapidly varied flow. Okay, gradually varied flow means the depth changes gradually over a long length of the channel is called as a gradually varied flow, and depth changes suddenly over a short span of the channel is called rapidly varied flow. See here, so you got the concept of the non-uniform flow is a gradually varied flow and rapidly varied flow. Okay, the gradually varied flow means the depth changes gradually over a long length of the channel and depth changes suddenly over a short span of the channel. Okay, see this is the uniform flow. Okay, this complete figure it shows the uniform flow and non-uniform flow. Okay, in non-uniform flow two categories is the gradually varied flow and rapid varied flow. Okay, uniform flow. Okay, here this is the uniform flow. Here we know y is equal to constant and v is equal to constant and discharge is equal to constant, because in uniform flow you already know the depth, velocity and discharge is not going to change with respect to the length. Okay, here at this section, okay, from this section y is constant, v is equal to constant and q is constant. Here is going to change because you know it is going to change with respect to the length. While seeing the figure only itself you can get the clear pictures. Okay, see here the depth is going to change, y1 and y2 is different. Okay, so here you got, now see here this is the uniform flow at this section from 1 to 2 is the uniform flow, and from 2 to 4 okay is the non-uniform flow. These are also two categories. You know in non-uniform flow there are two types, gradually varied flow and rapidly varied flow. Gradually varied flow means the depth of the flow changes gradually over a long span of the channel, and rapidly varied flow means sudden changes in a depth over a short span of the channel is called as a rapidly varied flow. Okay, next classification is laminar and turbulent flow. Okay, laminar and turbulent flow. The first one is laminar. See, laminar flow means the fluid particles or fluid layers, okay, fluid layers moves parallel to each other. Okay, moves parallel to each other. There will be no any lateral mixing is called as a laminar flow. Means this is only possible in a low velocity, in a low velocity. This is on a possible in a low velocity. Okay, the laminar flow means the fluid particles or the fluid layer it moves in a parallel to each other, and there is no any lateral mixing is called as a laminar flow. It is only possible in a low velocity. Okay, you also know if it is laminar flow, the Reynolds number Re is less than 500. Okay, if it is laminar flow the Reynolds number Re is less than 500. We also know Re is equal to rho Vr or divided by mu, or you can write as rho Vm divided by mu. Means is rho the density of fluid and V mean velocity of the flow, mean velocity of flow, and M hydraulic mean depth or hydraulic radius. So you can, the expression is A by P. Okay, hydraulic mean depth or hydraulic radius, A by wetted area by wetted perimeter. So you just check it here, the wetted area, see this is the, just show the trapezoidal section. Okay, here the top surface. Okay, this is the wetted area. Okay, this is the wetted area. So wetted perimeter means from point A to C, A to D. Okay, take it as a B C. Okay, from the point A to D means AB plus BC plus CD. This is the wetted area, wetted perimeter, right? So wetted perimeter is a AB plus BC plus CD, means here the base width B plus two sides, right? So the hydraulic mean depth or hydraulic radius is equal to wetted area by wetted perimeter. Wetted area, this is the wetted area, and wetted perimeter is from the, this is the wetted perimeter. Okay. So laminar flow means the water, the fluid particles, fluid layers moves parallel to each other, and there is no lateral mixing, and it is only possible in a low velocity. And if it is laminar flow, the Reynolds number is less than 500. Okay, Reynolds number, the formula or expression rho Vm by mu. Okay, so next go for the turbulent flow. What is turbulent flow? See here, already studied the laminar flow. In turbulent flow, the fluid particles or fluid layers, it moves in a zigzag manner. There is no any particular pattern. Okay, it moves in a zigzag manner and lateral mixing, and there will be lateral mixing because due to the high velocity. Okay, so you got the concept. In laminar flow, it is moves in a parallel to each other, and in a turbulent flow it moves in a zigzag manner. There is a lateral mixing because there will be a high pressure due to the high velocity. Due to the high velocity, the water fluid particles moves in a zigzag manners. Okay, so if in a turbulent flow the Reynolds number is greater than 2000, is a turbulent flow. Now the equation, okay, Reynolds number equation is the rho Vm divided by mu. Okay, means is directly proportional to the velocity. If the velocity is high, the Reynolds number will be the high. So here turbulent flow is occurs only due to the high velocity, and the Reynolds number is greater than 2000 is a turbulent flow. Okay, in laminar flow the Reynolds number is less than 500 is laminar flow. Okay, and the Reynolds number between the 500 to 2000. Okay, Reynolds number lies between 500 to 2000 is called as a transition state. Means the flow changes from the laminar to turbulent. Means the laminar to turbulent, you know, laminar is less than 500 and turbulent is greater than 2000. So if the Reynolds number is lies between the 500 to 2000,